learners, I welcome you all again to the lecture series of Database Management System. In our last lecture, we have seen database architecture, three-tier architecture of database management system. And also we have seen a very important concept of logical and physical data independence. In this lecture, we are going to start with data models. As you will proceed with this lecture, you will better understand what is data model. But in short, I must tell you what is a data model. See, in database, we are showing the data and the relationship among different data items. But how it is getting shown in the database? For that, before going to the real life implementation, we are making a model. In that model, actually, we are showing how data and the relationship among different data items will be shown. At first, the particular first data model actually that came into market was hierarchical data model. You will see what is hierarchical data model and why we had to discard. Then came network model, that also we discarded. And after that, E.F. Cott, he was a scientist, he gave us relational model. And from there only till today, we are following relational model, but definitely it has taken some extra shape. We have added some features to the relational model, but we are still following relational model or RDBMS. It's a very important concept because you will know how relational model is depicted. So stay tuned to my lecture and let's start.
So what is a data model? A database model defines the logical design and structure of a database for describing data, relationship among different data items. Semantics means meaning and constraints. Semantics means metadata. That means data about the data so that we can understand the meaning of that particular data. Constraint means the restrictions imposed on the data. That means we can say a data model, it defines how data will be stored in it, how relationship among different data items will be shown, how data will be accessed, how data will be updated, how the constraint will be shown, how the semantics will be shown in the data model. Understood? So this is called data model. Now, first data model that came to market, that was hierarchical model. This model, it was developed first by IBM in 1968. Okay, and after that we had to discard this hierarchical model, and ultimately network model came. Then for some reason also we had to discard network model. We will discuss all these reasons one by one in this lecture. So after network model was rejected, then ultimately we adopted relational model. So we will see all these three models one by one. We will start with hierarchical model. Now, what is a hierarchical model? Hierarchical data model is nothing but model in which data is organized into a parent-child relationship structure, where each record will have a parent record and that record can have many children. Understood? And the top node will be called root. That means I can say a root may have any number of dependents. Again, each of these dependent may have any number of dependents and so on. So you can understand this relationship is shown in terms of parent-child relationship or PCR. Understood? Now, each of these dependent can have any number of dependents. So it is growing like this. Parent-child relation is growing like this. We will discuss with an example, don't worry. That particular examples where hierarchical data model was implemented, that was given by IBM, that is called Information Management System or IMS. This is the first hierarchical model given by IBM, and Nomad by NCSS. Now we will discuss what is a hierarchical data model now. I have taken an example where I am showing that one supplier is supplying many parts. Okay, the problem statement is like this. One supplier is supplying many parts and one part is supplied by many suppliers. Now look at this supplier record and part record. Supplier is having supplier ID, supplier name as SID and supplier name as SNAME, supplier SSN as SSN, supplier city where he dwells, and amount. The supplier is supplying a particular amount of a particular part. Part record will have part ID, part name as PID and PName, part color and part city. Understood? Now look at this diagram. You can see from here P3. Suppose it is the first record. P3 is the first part record. So P3 name is ink. The color of this thing is blue and part city is Mumbai. This is supplied by supplier S1, whose name is ABC, whose SSN number is 444, or Kolkata is the city of that supplier, and S1 is supplying part P3 by an amount 500. Understood? Now, this part P1 is supplied by now two supplier. Again, I have to repeat S1's record as it is. Only the amount by which S1 is supplying part P1 is getting changed. It is now 250. But all other fields of supplier S1 is remaining intact. Supplier S2 is also supplying part P2. So we have created another child record, and PQR is the name of S2 and SSN number Mumbai and 250 is the amount of part P1. Similarly, part P2 is supplied by S1. I have created one child record for S1, one child record for S2 and one child record for S3. So you can see the record creation is not a problem. Now we will understand where actually the actual problem lies. You can see there is an insert anomaly in this particular parent-child relationship. Because what is insert anomaly in this case? We can't insert data about a new supplier if he has not yet supplied any parts. Suppose S4. S4 has newly joined, but it has not yet supplied any parts. So there is part record missing. Since there is no part record and part record is the parent record, so without parent record, S4 record cannot exist. That means I cannot insert S4's record. This is insert anomaly. Next comes delete anomaly. Delete anomaly is if we wish to delete any part. Suppose I want to delete any part, suppose part P4. It is not shown over here in the diagram. Suppose part P4 I want to delete. And that part is the only part supplied by some supplier. Suppose S5 is supplying part P4. Now, if I delete part P4 record, then S4's record also gets deleted. And you can't find S4's record in other parent-child relationship. That means along with part record, you have deleted the supplier record. This is called delete anomaly. This is also a serious problem. Update anomaly. If suppose the city of S1 changes in the future, then I have to update in so many places. And I have to search where S1's record is existing. Everywhere I have to do the update. Otherwise, there will be an update anomaly. So you have understood there is insert, there is delete, and there is update anomaly. And the most disadvantage of hierarchical model is that it does not support many-to-many child relationship between nodes, because a parent can have many children. This is the rule of hierarchical model, but a child cannot have many parent elements. So this is the drawback of hierarchical data model. Because of all these drawbacks, we had to discard hierarchical data model, and then came the next model, which is called network model. Now in network model, everything is remaining same. Only thing is that any dependent or any child can have more than one parent. Examples include UNIVAC, DMS-1100 and IDMS, Integrated Database Management System. This was given in 1969 by IBM. So let's understand network data model with the same example. One supplier is supplying many parts and one part is supplied by many suppliers. This is the network data model view. You can see from here, I have created first a connector record for a supplier. To create another connector record for the parts. Let's understand in detail. Suppose this 250. This 250 is having record from S1 and another record from part P1. That means S1 supplies part P1 by an amount 250. Again, 250 is linked to 300 and this 300 is linked to P2. Means S1 is supplying part P2 by an amount 300. Now look at this 500. 500 is supplied by S1 because same record is continuing, same record pointer is continuing, but S1 is supplying part P3 by an amount 500. S1 is supplying no more parts, only part P1, P2, P3. That's why I have ended this connector record over here. Now look at part P1's connector record. Part P1 is connected to first this 250 because it is supplied by S1. Again this 250 is connected to 250, this over here. This 250 is connected to S2. That means part P1 is supplied by S2 by an amount 250. Understood? And part P1 is only supplied by S1 and S2. So I have ended up this 250 over part P1. Similarly, I have to do for S2. That means for S2, I have to create a connector record 250, 500 coming back. Again, for part P2 also, I have to do this kind of connector record. So from here, you can understand this is a very, very complex structure, isn't it? It's a network data model is a very complex structure, but it had some advantages. Let's understand first its advantages. So first advantage is that insert operation for a new supplier record, there will be a single pointer because suppose I want to add some record, insert some new supplier record in the database, then what I have to do, because now you can see there is no connector record existing because no 250, 300, this thing is existing because that new supplier has not supplied any parts. So what should I do? For that, I will create a single pointer starting from it and ending to itself. So you can see from here, S1, suppose S4 has newly joined, then S4 will be starting from here. There will be one connector record and it will be ended up over here to indicate S4 has not yet supplied any part. Delete operation. To delete any shipment, just delete the connector record. Then it will be deleted. But mind that after deleting that connector record, lot of pointer rearrangement is necessary, isn't it? Suppose if you delete this 300, in the last part of this S3's record, if you delete this thing, naturally a whole pointer rearrangement must be done. This is another cumbersome operation. Update operation, this is also easy and that is also not giving any kind of anomaly because each record appears only once. So update is very easy. And network data model, definitely it can show many-to-many relationship in a seamless manner. But what is the disadvantage? I think you have already understood that the overall structure is very complex and mostly this is managed by pointers, and pointers are used to express the relationship between records, and pointer management is always a very, very complex task. You can appreciate this fact. That's why we had to discard this network data model, and ultimately EF Cod gave a very simplistic solution which was called as relational data model. You can see from this particular diagram that data is organized logically in the form of rows and columns. Okay, this is called rows and this is called column. Each relation or table is a collection of columns. Thus, columns are also called attributes and rows are also called tuples. Okay. So, where the column represents the attribute of an entity and attribute of any object. Okay. And suppose student is the entity, then student's roll number, name is the attribute, and the rows represents the tuples represent the student's record. And also remember, the most important thing is that a table or relation is only used to represent the relationship between records. So let's take again the same example where one supplier is supplying many parts and one part is supplied by many suppliers. We are implementing this thing in a table structure. So you can see I have created a supplier table. I have created a parts table, but the shipment quantity, for shipment quantity, I will show another table. That means this relation between supplier and parts is shown in the table structure itself. And since the table has got a formal name as relation, that's why this model is called relational data model. Understood? So relational data model is showing the supplier record in one table, parts record in another table, and shipment or the relationship is another table. So relational data model is that model where data and the relationship among different data items are shown in table structure itself. With this, I am concluding my lecture today. Please try to understand all these models one by one, and then you will appreciate why relational model has been adopted in place of hierarchical and network model. Thank you for your patient hearing, and stay tuned for my next video. Thank you so much.